Picture this. A world encased in ice. A frozen wasteland, stretching as far as the eye can see. This isn't a scene from a science fiction movie, but a glimpse into Earth's distant past, during one of the most dramatic climate events in our planet's history. Journey back in time with me to the Precambrian era, roughly 2.4 to 2.1 billion years ago. Our planet was a very different place then, teeming with primitive microorganisms in its ancient oceans. But a cataclysmic change was about to unfold. One that would reshape the face of the Earth and set the stage for life as we know it today. This pivotal moment in Earth's history is known as the Great Oxidation Event. It marked a turning point when oxygen levels in our atmosphere began to rise dramatically. But why was this such a big deal? Well, imagine if the air you breathe suddenly became toxic to most life on Earth. That's essentially what happened to the dominant life forms of the time. You see, the Earth's early atmosphere was rich in methane, a potent greenhouse gas that kept our young planet warm and cozy. But as oxygen levels surged, it reacted with the methane, effectively removing this thermal blanket from our atmosphere. The result? A sudden and severe global cooling that plunged our planet into a deep freeze. Scientists believed this cooling was so extreme that it may have turned Earth into what they call a snowball Earth. Picture our blue marble transformed into a giant snowball hurtling through space, its surface almost entirely covered in thick sheets of ice. From the highest mountains to the deepest oceans, ice reigned supreme. This global deep freeze had profound consequences for life on Earth. The anaerobic microorganisms that had thrived in the oxygen-poor environment suddenly found themselves facing extinction. It was a mass die-off on a scale that's hard to comprehend. But as the saying goes, when one door closes, another opens. The demise of these ancient microbes paved the way for the evolution of new life forms that could tolerate and even thrive in an oxygen-rich world. Now, you might be wondering, how do we know all this happened billions of years ago? Well, the Earth itself has left us clues. Geologists have uncovered ancient glacial deposits in places that were once near the equator during this time. These frozen time capsules have been found in diverse locations across the globe, from the rugged landscapes of Canada to the sun-baked plains of South Africa and the bustling subcontinent of India. These glacial deposits tell a story of a world in the grip of ice, where glaciers carved valleys and deposited boulders in places that today bask in tropical heat. It's a testament to the dramatic changes our planet has undergone over its long history. But the story doesn't end there. This ancient ice age, as severe as it was, eventually came to an end. The Earth's resilient systems kicked into gear, volcanic activity increased, and greenhouse gases once again built up in the atmosphere, slowly thawing our frozen world. As the ice retreated, it left behind a changed planet. The oxygen-rich atmosphere that had triggered this global cooling event would go on to support the evolution of more complex life forms. In a way, this ancient catastrophe set the stage for the rich biodiversity we see around us today. So, the next time you feel a chill in the air or see frost on your window, take a moment to reflect on this ancient chapter in Earth's history. Remember that, long before humans walked the Earth, our planet experienced climate changes on a scale that's hard to imagine? It's a humbling reminder of the forces that have shaped our world and continue to influence it today. From a frozen wasteland to the vibrant planet we call home, Earth's journey through time is a testament to the resilience of life and the nature of our world. As we face our own climate challenges today, perhaps we can draw inspiration from our planet's ability to adapt and evolve in the face of extreme change.